Bismillahirrahmanirrahim. Welcome to the second part of this lecture, in which that we are going to speak about the sequences or the limit of the sequence. In the first part, we spoke about the sequence. We gave examples, how to generate the first 5 terms and how to find the general formula of the nth term. And also we gave the definition of the sequence. In this part, we are going to speak about the limit of a sequence. As we said before, sequence is a function, but the domain for that function is just the positive integers. That also, since it is a function, and sometimes, in some cases, it has limit. Some other cases, it doesn't have limit. And the sequence, as we said, is a discrete function. We can say that is just points. It's as values. It is not continuous function. This will be the general form or the graph for a given sequence. So the limit of a sequence, or we can say a sequence, a sub n has a limit L, and it's written as limit as n goes to infinity for the nth term equal to L, or a sub n is approaching the number L as n goes to infinity if we can make the term a sub n as close as L as we like by taking n sufficiently large, like what we have in this figure. The sequence is going to approach this value equal to 1. We can choose n very large so that the nth term will approach the value of 1. If the limit of the nth term exists, then we say that the sequence is convergent or converges. Otherwise, we say the sequence diverges. It doesn't approach any specific number. So we have two types of the sequences: divergent and convergent. Convergent sequence if the limit of the nth term exists, or if the nth term is approaching certain value. If it doesn't, we call it diverge. For example, this figure showing that the sequence is approaching this number, L. So this sequence is convergent. Also, this sequence with some going up and down, but at the end, it is approaching the number L, so it is convergent. So these are two examples for convergent sequences. And as I said, this is not a continuous function. So let's speak about the nth term. As we're choosing n very large, that nth term is approaching certain number. If it does, we say the sequence converges. If it doesn't, if the sequence diverges, if the term do not approach a single number, and we have two times, either the n or the nth term is not approaching a certain number. For example, if we choose a sub n equal to -1 to power n, this will be either the value for the term of the sequence either will be +1 or -1. It is between 1 and -1, and the nth term will not approach a single number. So we say this is diverge. Or when the sequence goes for the infinity, we take the limit for the sequence, we go for the infinity, we say that the sequence also diverges. So either the limit will go for the infinity, or if the nth term are not approaching a single value, it can be between two numbers. We say that sequence diverges. As we had for the continuous function, also we have lots for the limit of the sequence. So for that we have a sub n and b sub n. These are two convergent sequences. Let's speak about now the convergent sequences. Then the limit of their sum, a n plus b n equal to the sum of their limits. And the limit of their differences will be equal to the difference of their limits. constant, multiple law. We multiply the sequence by constant, we can take the sequence outside and, or the constant outside, and we find the limit of the sequence. Also, the multiplication of two sequences will give me the product of their limits. And the quotient law, limit of a sub n divided by b sub n will equal to the limit of a sub n divided by the limit of b sub n, provided that the limit of the b sub n is not equal to 0. Let's have some examples. Suppose that I want to check whether the given sequence is convergent or divergent. Example question number 27. I need to check a sub n as 5 over n plus 2. All what I need for this one to find the limit. Let's find the limit of a n as n goes to infinity. Limit of 5 over infinity. For this one, we'll take the highest power of the denominator to check. The highest power of the denominator. Or in some textbooks, they are saying that we can divide by the highest power. So I can say it is limit divided by the highest power up and down of the denominator. It is 5 over n. This is 1 plus 2 over n as n goes to infinity. Now this one will give me 0. This is 0. So I will have 0 over 1, which is equal to 0. So the limit for this sequence is equal to 0, or the nth term is approaching 0. So we can say this sequence is convergent. Convergent. The second one, 28. 5 is equal to 20 plus 1. 28. Let's find the limit, or it is 5 multiplied by, I have constant outside, and this is n plus 1 as n goes to infinity. This 5 multiplied by the limit, but we know that the quantity of n plus 1 as n goes to infinity will go for infinity. So this sequence is divergent. It diverges. More example. 29. Limit of this one, which is 4 n squared minus 3 n divided by 2n squared plus 1 as n goes to infinity. So equal to limit divided by the highest power of the denominator, which is n squared in this case. I will have 4 minus 3 over n divided by 2 plus 1 over n squared. This is equal to 0. This is equal to 0. I will have 4 over 2, which is equal to 2. So it is divergence. The limit exists, and the nth term is approaching a certain value, which is 2 in this example. For number 31. Limit of n to power 4 and n to power 3 minus 2n, and goes to infinity. can say simply, we will take the highest power up and down. We have, so I'll have n to power 4 divided by n to power 3 as n goes to infinity. N to power 4 divided by n to power 3, this will give me limit of n as n goes to infinity, and this will equal to infinity, which means the sequence diverges. So this is the idea of convergent sequences or divergent sequences. We need to find the limit of the nth term and check whether the limit exists or does not exist. If the limit exists, then we say the sequence is convergent. If the limit does not exist, either we'll go for infinity, or for it is not approaching a certain number, we call it divergent sequence.